Hi, this is Nirmala Rednam. In the last video, we had started the topic rational numbers from NCERT textbook class 8. I explained the definition of rational numbers and closure property on rational numbers. In this video, I am going to explain the commutative property on rational numbers. So what do we mean by commutative property? As in the previous property, we will be starting with a set S and a mathematical operation. Suppose I have a set S and a mathematical operation. We say that the given mathematical operation is commutative for the given set S whenever for any A, B belonging to the set S, A operation B is equal to B operation A. I repeat, we say that a mathematical operation is commutative for a set S whenever for any A belonging to the set S, A operation B is equal to B operation A, right? So now we are going to check this property for the three sets, that is the whole numbers, the set of integers and the set of rational numbers, right? So let us take any two A, B belonging to the set of whole numbers, okay? Now we had taken 3, 5 earlier. Let us continue with that. You can take any two elements. 3, 5 are two elements belonging to the set of whole numbers. Now, if my mathematical operation is plus, what is A plus B? 3 plus 5. What is B plus B operation A? 5 plus 3. So what is 3 plus 5? Equal to 8. 5 plus 3 is also 8. So what does this mean? This means that addition is commutative for the set of whole numbers, correct? Now coming to subtraction. A operation B is 3 minus 5. B operation is 5 minus 3. Now 3 minus 5 will give me minus 2. 5 minus 3 will give me plus 2. Now clearly these two are not equal, so we can conclude that subtraction is not commutative for the set of whole numbers. Now coming to multiplication. Again 3 into 5 will give me 15. 5 into 3 also gives me the same number 15, which means that multiplication is commutative for the set of whole numbers. Now coming to division. 3 divided by 5, 5 divided by 3. Okay, these are clearly not equal. In fact, they don't even belong to the set of whole numbers. So we can conclude that division is not commutative for the set of whole numbers. Okay. Now we will look at the set of integers. So we are looking at the commutativity of integers, right? So here let me take any two integers. I am going to take minus 3, 5. Now what is A plus B? Minus 3 plus 5 equal to 2. What is B operation A or B plus A? 5 plus of minus 3. Now this is again 2. So we can conclude that addition is commutative for the set of integers. Now if you look at subtraction, A operation B is minus 3 minus 5, which is minus 8. B operation A is 5 minus minus 3, which is 5 plus 3, which is 8. Clearly these two are not equal, so subtraction is not commutative for the set of integers. Next, if you look at multiplication, minus 3 into 5 will give me minus 15, whereas 5 into minus 3 will give me minus 15 again. Therefore, multiplication is commutative for the set of integers. Now if I look at division, minus 3 divided by 5 compared to 5 divided by minus 3. These two, like I said earlier, they are not integers in the first place and clearly they are not equal. Therefore, division is not commutative for the set of integers. Now let us come to our rational numbers. So here for rational numbers, I am going to check commutative property, right? So now take any two rational numbers. Right, okay. So let us take 3 by 5 minus 3 by 5, 2 by 7, right? Now a plus b, this is addition, subtraction, multiplication and division. So a plus b is going to be minus 3 by 5 plus 2 by 7. We will take the LCM, which is 35, minus 3 into 7 plus 2 into 5. This is nothing but minus 21 plus 10 by 35, which is equal to minus 11 by 35. Now if I look at b plus a, which is 2 by 7 plus minus 3 by 5. Again I am going to take the LCM, which is 35, right? And this is going to be 2 into 5 plus minus 3 into 7, which is nothing but 10 minus 21 by 35, which is again minus 11 by 35. So clearly I can conclude that addition is commutative for the set of rational numbers. Now let us come to subtraction. Minus 3 by 5 minus 2 by 7 is equal to 35 minus 3 into 7 minus 2 into 5, which is equal to minus 21 minus 10 by 35, which is equal to minus 31 by 35, right? Now if you look at b minus a, what is b minus a? My 2 by 7 minus of minus 3 by 5. Again I am going to take the LCM here, 35. So this will give me 2 into 5, minus of minus will become plus 3 into 7, which is 10 plus 21 by 35, which is equal to 31 by 35. Now clearly these two are not equal, therefore I can conclude that subtraction is not commutative for the set of rational numbers. Now coming to multiplication, I have minus 3 by 5 into 2 by 7, which is minus 6 by 35. And if I take 2 by 7 into minus 3 by 5, this is again minus 6 by 35. Because you know that when you're multiplying two rational numbers, you can multiply the numerators by and multiply the denominators. Now here you will see that multiplication is commutative for the set of rational numbers. Now coming to division, minus 3 by 5 divided by 2 by 7 is equal to, as we have discussed earlier, you will be putting multiplication here and this will become the reciprocal. So this is nothing but minus 21 by 10. When it comes to b divided by a, that is 2 by 7 divided by minus 3 by 5, this can be written as 2 by 7 into minus 5 by 3, the reciprocal. This is nothing but minus 10 by 21. Now you will see that these two are not equal, therefore division is not commutative for the set of rational numbers. numbers, right? Now let's quickly look at what they have given in the textbook. So as you can see here, they have checked for whole numbers, right? And they have seen that it is commutative for addition is commutative, subtraction is not commutative, multiplication is commutative, and division is not commutative, right? Here they have left a few things blank where you can put some numbers and see, as we have checked just now. And when we come to integers, again in the table they have left a few blanks. As an exercise, you can simply take any two integers and check like we have just done. So here also you will see that addition is commutative, subtraction is not commutative, multiplication is commutative, division is not commutative, right? And then comes our rational numbers, where we have to carefully take the LCM and add and see. And they have taken a few examples like we have done, and they have concluded that addition is commutative for rational numbers, subtraction is not commutative for rational numbers, multiplication is commutative for rational numbers, and division is not commutative for rational numbers, right? Now here, like for closure property, they have given a small table which you can fill out to check which operation is commutative for which set. Okay, so you will see that we have checked addition is commutative for rational numbers, it is commutative for integers, whole numbers, natural numbers. Subtraction is not commutative for any of the four sets, right? Multiplication is commutative for all the four sets, and division is not commutative for any of the four sets that we know, right? So here with this we complete the commutative property for rational numbers. Now here I would like to give a small activity to make you understand commutative property in a fun way. So let us look at this. I want you to take an A4 sheet . Right? And as you're already familiar, I'm sure that in your childhood you have already played this game tip top, right? So let us quickly make that model here, and we're going to be filling out the different blanks for that. So if I have this, this is how it is done. First we are going to fold it into 4 squares. Right? And then we are going to make the folds like this. Right? And now we're going to fold it one more time in this fashion. Right? I'm sure by this point all of you are able to recall the game that I'm talking about. Probably it has a different name in different regions of the country, but usually it's known by the name tip top, right? So here you have 4 options that you can fill out. So what I want you to do is, so this is the model, right? So what I want you to do is fill out the different regions here. Because we have 4 sets, I can easily write it as set of natural numbers, right? And then the set of whole numbers, then the set of integers, and the set of rational numbers, right? Now coming to the inside, so when I open this, I need the 4 mathematical operations, right? So let us write this as add, multiply, right? Let this one be subtract and division, minus and division. Okay, now you fill out the rest of them in the same manner, plus, into, divided by, minus, right? Now inside you are going to write the final result. Okay, so if you were to play with this game with your friends, they have to select any one of the given sets, right? For example, if you choose whole numbers, then it is going to be W H O L E, right? And then you will say choose any one of the 4 mathematical operations here, right? So if they chose, for example, minus, right, then you can open minus and check. So you can say that subtraction is not commutative for the set of whole numbers, right? Now here, in order for this to work, you have to be very careful about how you choose the pairs of the mathematical operations and what you write behind it. Okay, that's the only trick here, and it's just a fun way to look at the commutative property for all the 4 sets, for all the 4 operations, all in one single game, right? With this, we come to the end of this particular subtopic, that is the set of rational numbers. That is commutative property for the set of rational numbers. So in the next video, we will be looking at the associative property for the set of rational numbers, right?